find the volume. And this is a problem we've done before, actually, but we're going to do it with cylindrical shells now of the solid obtained by rotating the y-axis, rotating about the y-axis, the region between y equals x and y equals x squared. So again, this is something a region we've looked at before, y equals x squared. We've drawn it in the past, so I'm just gonna draw it again like we did before. So 0, 0, and 1, 1 is where they intersected. Y equals x is a line. I can draw. And then I have this parabola here. And they tell me I'm rotating about the y-axis. I want to use cylindrical shells for this. And so my strips, normally in the past, when I was doing discs and washers, they went horizontal, but now I'm doing parallel to my rotation, so my strips are going to be up and down here. Okay. So your radius is still going to be x, and that's my integration variable. But now your height, the height fluctuates. It's always between the strip. It's between these two functions, right? The line and the parabola. So the height, I'm going to find it by taking the height of the first one, and then I'm going to subtract off. I counted too much height, so I'm going to subtract off that little extra bit of height. So the height is going to be x minus x squared. The x represents the blue line height, and x squared represents the little red that I'm subtracting off.
So on the last one, you could just use f of x because the bottom was
the bottom of my region was at y equals 0. But here, the bottom of my region is this parabola. Yeah. So in general, if you have a top and a bottom, it would be the difference. Just like it was for area, you did top minus bottom, same thing here. Okay, once you have your radius and your height, you're ready to go on cylindrical shells. So my volume is the integral 2 pi. R is x. My height is x minus x squared. And what are my bounds on my integral?
0.
0 to 1. A range of my x values. It went from 0 to 1. Okay, so factor out the 2 pi and distribute my x, so I get x squared minus x cubed. You integrate that. So you'll get x cubed over 3 minus x to the 4th over 4. So you should get 2 pi 1/3 minus 1/4, or pi over 6. If you look back in your notes, when I told you we did this problem with washers and discs, we got the same answer, pi over 6. And if you should compare these two and see which one is better. I think this method is a little bit easier here, integrating this. If you look back at the washer and the disc method, I had to integrate in terms of y, which meant in my equations, I had to solve for y. So in this, or I had to solve for x. So y equals x squared, I would get x equals the square root of y. So when we did washer and disk, we had square roots, which usually make things more complicated. Not very much, but they do. So this way is a little bit better for this one.